Hi, this is Les and Amy from the RevGenetics Podcast. You can listen to the podcast on YouTube and now on Spotify, where we do a deep dive on supplements and longevity studies.
Today we are really digging into a fascinating piece of research. It's right at that sweet spot between natural compounds and, well, some very advanced nanotechnology.
And the mission here is to tackle one of the most frustrating parts of aging, right? These zombie cells.
That's the term. I love it, too, because it's so accurate. We're talking about senescent cells.
Okay, so these are cells that are damaged, they've stopped dividing, but they just won't die.
They just hang around, clogging everything up. And while that happens naturally as we get older, today's deep dive is on something more specific.
Therapy-induced senescence.
Exactly. TIS. It's what happens after certain medical treatments, especially chemotherapy. The drug they looked at here was doxorubicin.
Right, so the chemo does its job, kills the cancer, but it leaves behind this army of zombie cells.
A huge population of them, and that's what creates a really high risk for the cancer to come back or get worse.
Why is that environment so risky? I mean, they're not dividing anymore.
No, but they're not quiet. They're actually very metabolically active. Think of them as tiny factories just constantly leaking toxins.
That's the SCSP we've talked about before, the senescence-associated secretory phenotype.
That's the one. And this toxic soup they leak out drives inflammation, it damages the healthy cells next door, and it basically rolls out the red carpet for cancer to return.
So if we want to fix the problem, we have to stop the leak. What specific toxins did this study focus on?
They went right for the big ones, the main drivers of this kind of inflammation, interleukin-6 and interleukin-8.
IL-6 and IL-8.
Yeah. These aren't minor signals. They basically put the whole area on high alert, creating chronic damaging inflammation.
So the mission then was to find a better way to deliver a compound, Fisetin, to stop those specific leaks.
And to do it with nanotechnology for pinpoint precision. That's the whole game.
Okay, so let's get into the source material. This all comes from a doctoral dissertation, right?
It does. The title is The Influence of Fisetin-Loaded Liposomes on Therapy-Induced Senescent Cells. A bit of a mouthful.
But it tells you everything you need to know. Let's break down the players. First up is Fisetin.
Right. Fisetin is a natural flavonoid. You find it in things like strawberries, apples, onions. It's a powerful compound.
So what's the problem? If it's so great, why don't we just use it?
The problem is delivery. Fisetin is what we call water-insoluble.
So it's like oil in water.
Exactly like oil in water. It just clumps up. Your body is mostly water, so it has a really tough time absorbing it and getting it where it needs to go.
So you can't get a high enough concentration to the actual zombie cells.
Not with just, taking it orally. It's not precise enough for this kind of job.
So you need a boat, a special delivery truck to carry the oil through the river.
That's the perfect analogy. And that's where the liposomes come in. These are the nanocarrier.
Tell me more about those.
Think of a liposome as a tiny, hollow fat bubble. It's an engineered sphere with a fatty outer layer, and they are microscopic, between 95 and 116 nanometers here. Incredibly small.
And because Fisetin is the oil, it can hide inside that fatty bubble.
Precisely. It's protected from the watery environment of the bloodstream. It lets it travel safely and, hopefully, directly to the target.
The senescent cells that are spewing out all that IL-6 and IL-8.
Right. This whole field is called xenotherapy, and it really has two main goals.
Okay.
The first is what we call senolytics. That's the search for a compound that can selectively kill the zombie cell. Just get rid of it.
The kill switch. And a second.
The second approach is xenomorphics.
Okay, and that is...
That's more subtle. If you can't kill the cell, can you at least shut it up? Can you quiet it down?
Stop the toxic SAC leak.
Exactly. Turn off the factory that's pumping out IL-6 and IL-8, and that's really where the study found its success.
And to test this, they used a model that mimicked the real-world problem.
They did. They took two kinds of lung cells, A549, which are lung cancer cells.
The bad guys.
And WI38, which are healthy lung fibroblasts, the good guys. And they deliberately turned them into zombie cells using that chemotherapy drug, doxorubicin.
So they created the exact problem they wanted to solve.
A perfect lab model of therapy-induced senescence. Then they brought in the Fisetin nanobubbles to see what would happen.
Couldn't do today's episode without support from RevGenetics.
RevGenetics is committed to quality research, bringing the most effective longevity compounds, like Fisetin, which we are discussing today, to your daily regimen.
We're back. So before the break, we set the stage. They created zombie cells in the lab, and we're ready to see if Fisetin could fix the problem. Let's start with the first goal. Senolytics.
Right, the kill switch. Did Fisetin selectively kill the zombie cells?
And the answer was?
A pretty clear no. In this study, in these lung cells, Fisetin was not senolytic.
Really? That's surprising.
It is, but the data was clear. Now, if they used really, really high concentrations of Fisetin, we're talking doses that are just not practical,
What?
it did reduce cell viability. It did kill cells.
But there's a but, isn't there?
A huge one. The key is selectivity. The high doses killed everything. It killed the senescent cells, but it also killed the healthy, non-senescent cells right alongside them.
So it wasn't a sniper rifle, it was a grenade.
Perfect. It lacked that surgical precision you need for a good senolytic. So, on that front, the mission failed. Fisetin was not the zombie cell assassin they were looking for.
Okay, so if it failed as a killer, why are we so excited about this research? This must be where the pivot to xenomorphics comes in.
This is where it gets really interesting, yes. Because while it failed as a killer, it was a spectacular success as a cell calmer.
It was xenomorphic.
Highly xenomorphic. It was incredibly good at shutting down those toxic leaks. It successfully modulated the SASP.
And the key question, did putting it in the nanobubble, the liposome, actually make a difference?
A huge difference. First, they showed the bubbles themselves were completely safe, not toxic at all. And then, even though getting the Fisetin inside them was tricky, the efficiency was only around 13–14%, that active encapsulation made it so much more powerful.
It amplified its effect.
Massively. Let's look at the cancer cells first, the A549 line.
The high-risk group, what happened to their toxic leaks?
The results were dramatic. The lipotome-encapsulated Fisetin cut the levels of both IL-6 and IL-8 by more than half.
More than half, wow.
Compared to the untreated zombie cancer cells. So you're not killing the cell, but you're disarming it. You're neutralizing its ability to create that inflammatory environment that helps cancer grow back.
That's a huge win right there. It turns a dangerous place into a much quieter, safer one. So the delivery system made Fisetin a super effective inflammation blocker.
In that tumor environment, yes. But the results in the healthy cells, the WI38 fibroblasts, were even more astonishing.
Better than in cancer cells.
Oh, much better. In the healthy lung cells that had been damaged by chemo, the encapsulated Fisetin was so efficient, it brought the IL-6 levels all the way down to be on par with the healthy, untreated control cells.
So it completely reversed the damage from the chemo.
For IL-6, yes, it brought it back to a healthy baseline. But with IL-8, it was even better.
How can you get better than baseline?
Well, the encapsulated Fisetin dropped the IL-8 concentrations to levels that were actually below the healthy control.
Wait, say that again. It made the environment cleaner than the cells that were never even damaged in the first place.
That's what the data says. It wasn't just repairing damage. It seems to have been actively optimizing the cellular environment, making it healthier than a normal baseline.
That's incredible. So the big takeaway here is that the delivery system is everything.
It fundamentally changes what a compound can do. Even if Fisetin isn't a universal zombie cell killer, if you package it right, you can turn it into this incredibly precise cell calmer.
It neutralizes the dangerous signals that drive aging and disease, and it protects healthy tissues in a way that just taking a pill never could.
Right. It suggests that the future isn't just about finding new wonder drugs. It might be about finding new, smarter ways to deliver the powerful natural compounds we already know about. We hope you found today's discussion on how Fisetin nanobubbles could help manage toxic cellular leaks insightful. Thank you for listening to the RevGenetics Podcast.
RevGenetics.com for the best longevity supplements on Earth.